Very good. 18 inch.
1800.
Very good. Here's a big one, 26 inch.
4900.
4600. 46, 49. Is he with his 10%?
Yeah.
Okay, these are all supplies now. This is supply measurement you did.
Porque te dan 10%.
Now you're going to do return. What is return?
0.1.
0.1 or 0.1. 0.1. So these are going to be returns now. Now, you notice that the returns are a little larger. You want it to be a little larger in the house. You want to bring the return back to that unit right away. Here's an example. How many have been to Vegas? Rio. Remember the Rio? You walk into the Rio, you don't, it dissipates the smoke. People are smoking and it dissipates it. Right away. You've got a good return system in there. Excellent return system. Some houses have a very poor return system. Some of these homes. They required more returns, but they don't put them because of the budget. So here we go with returns. You're going to use 0.1. I'm going to give you some measurements. These are going to be a little difficult.
Okay.
Remember, you can use 10% negative or positive, but on returns, you always want to be in the positive side. Always on the positive side. Some returns will be 10%, some will be 20%, and some will be 30%, based on the application of the business. Mostly commercial business will use a higher percentage on returns.
Can we use that back as a paper?
Yeah, you use the same paper, because you're going to hand that in. Okay, here we go. I'm going to give you your measurements. Now I'm going to think a little bit, gentlemen.
Okay.
Are you ready?
Yes.
I'm going to use my 10% negative or positive. These are, yes sir.
No.
Okay, these are all returns. 0.1 you'll be using. First measurement is number 1, it'll be 12 inch. Number 2 will be 14 inch. Number 3 will be 18 inch. Number 4 will be 12.5 inch. Number 5 will be 14.5 inch. Number 6 will be 16 inch. Number 7 will be 20 inch. Number 8 will be 10 inch. Number 9 will be 18.5 inch. And number 10 is 18.75 inch.
18.75?
Yes, sir. Good luck.
Okay.
You say that the first one.
18.5, yeah.
Want to make sure you're thinking, sir.
Okay. Number 1 is 12. Para return. I got 700.
Best day of your life. You've already learned how to make some money. Yes. Yes, sir.
They have an app for it.
Yeah.
On the iPad. You just
How to make money?
How to make money? Acres
Oh,
of diamond.
no, an app, a calculator app.
Yeah. You can do a calculator app. They have an app. If you guys go on your laptop or
iPhone or iPad.
iPad, iPhone, whatever you have, you can go on the tells you what to do. I like to use the old-fashioned way, so I train you the old-fashioned way. So at least you can have something to pull out for the customer, because customers can't see your laptop or your app. So it's nice to have that. Okay, let's go. Let's go to page 9.6 in your book, please. How many of you have a yellow, what do they call that?
Highlighter?
Highlighter, there you go. Okay, you need to buy one. A yellow one and a blue one. At the 99-cent store.
What page?
9.6. Did you go outside for break?
Yes.
Who'd you talk to?
My wife. I gotta see how my kids doing.
What did I share to do when you went outside?
Just come to you.
Should have come to one of the students and asked them what's up.
I don't know.
After class is over, get with one of the students, ask them what you need for the class.
You got it.
I love it.
A mí me lo prestaron. Un amigo viene, él viene los
Here we go.
acaba de terminar el primer curso.
There's some of these sections that I'm going to read to you, but I'm going to idle for a minute because I want you to think about it. You don't have a book?
No.
Next step is get with somebody that has a book, okay? Sit by somebody that you can read with. They got books over there. Got books over there.
All right.
You have a book, young man? Get with somebody. We have books all over the place. Get with somebody. Okay, let's go. On figure 6, shows an air distribution system for a typical single-story home. You hear what it says? Single-story home.
What page is that?
9.6.
Oh, it's a 9.7.
9.7,
It's a drawing.
No, not the drawing, I'm reading.
Oh, okay.
Okay.
I'm sorry. Section 2.2.0.
Okay.
Are we okay now?
Yeah, we're good now.
Okay, very good. I'm sorry. I didn't know we were in the military. Yes, sir. Okay, are we ready?
Ready.
We will discuss the airflow in the system in detail to what? Demonstrate the concept of pressure relationship you will have learned so far, and some new ones. Generally, more airflow is needed for the cooling than for heating. So what are they saying? You need to have more air for cooling than you would for
Heating.
Most air conditioners will give out more air for cooling and less air for heating, which means the unit will run on a high speed for cooling and a low to medium speed on heating. Okay? Heat always what?
Rises.
Where am I here? Therefore, the air handler, which is called the furnace or the air handler blower, must be able to supply volume of air needed for the cooling mode. In this example, that a 3-ton cooling are required. As a rule of thumb in the HVAC, cooling required about 400 CFM plus what? Of air per ton of cooling. So that means that 400 CFM is equal to how much cooling? 1 ton.
1 ton.
Now it says here 450 per equals to 1 ton. Is that right?
Yeah.
Yeah, because it's in the 10%.
Yeah,
Plus or minus 50 per 50.
10%, yes.
Ah.
So, as a rule of thumb, for every 400 CFM is equal to 1 ton of cooling. Yes, sir.
When I went to pick up the duculator, and I was picking those guys' brain, they said when a house is tight, it's 400. When it's an old house, rule of thumb, it's 500. Is that true?
Let's hold on to that for a minute.
Okay, all right.
But we won't get there yet. We just want to learn some basics, and then we'll talk about more specific. But hold on to that, okay?
Okay.
Okay, here we go. Therefore, the blower in the system must be capable to supply the airflow of 1200 CFM. That means that the furnace must be designed to deliver, using the blower motor in the furnace or the air handler, to deliver 1200 CFMs of air, which is equal to 3 tons of air conditioning, plus 400 CFMs per 3 tons or more. Assume that the blower delivers a static pressure of 1.0 inches water column. That's what WC stands for, and we're going to talk about that a little later on. That the supply and the return ducts have extreme static pressure of 0.5 in water color equal and minus 0.5 water color, as shown. Now, let me share this with you. We're gonna talk about we're gonna talk about static pressure and velocity in a little later on, so you're gonna understand the difference. But at this point, we understand that 400 CFM is equal to 1 ton of air conditioning, okay, which is equal, 400 CFM is equal to 400 square feet of a home. Living, what?
Space.
Space. As shown, the system has 11 supply outlets, each requiring 100 CFM. So if it's 100 CFM, how many square feet of area is it covering?
1,100. What?
100 CFM, how much area is that covering?
Oh, 10 by 10. 100 square feet.
100 square feet,
I'm sorry,
which is
100
equal to what size of room?
10
10 by 10.
Okay.
So it's a 10 by 10 room. It's real simple. So it's small little room, right?
Yeah.
Maybe it's a motel or it's a...
So, wait a minute, it's got 11 air supply outlets and each one is
Right.
covering a 10 by 10 room?
Could be, you never know.
I don't know. That's what we're
What?
we don't care how they live. We just want to make sure they get the right area.
Oh, okay.
Don't
All
worry
right,
about
I'm
who's
just
living
saying, you know how many 11 rooms
here we
by
go.
10 by 10? Okay.
And two smaller outlets, each required 50 CFM, which is a very small area. The return air into the system through two centrally located grills. While supplying the system, consider the entire home as part of the system. Did you hear what it said? The required entire home as the system, the required system. So does that mean the closets? Yes. Does that mean the bathrooms? Yes. That means mother-in-law's bedroom?
Yes.
Yes. Everything.
Garage?
No.
No.
Now, there are some garages that are converted into apartments, which is fine. Not to code. But there are some requirements that are required if you're going to condition that space. And we'll talk about that a little later on. And your city might not like it, depending on where you live. But, well, okay. Okay, let's see. The supply air leaving the supply registers sweep the walls of the house. What do you mean sweep the walls of the house? Let's take a look at the front of this grill here. This is a split system air conditioning, which we consider a heat pump. And the heat pump it heats the room and it cools the room. The heat pump does not use any gas. What it does, it has a regular compressor in there, just like air conditioning. And in order to get the heat in here, it has what they call a reversing valve. So in the summertime, you have the heat on the outside of the unit and the cool air coming in, right? In the wintertime, you have the opposite. It uses a reversing valve. So then you got the heat that used to go to the outside in the summer, now comes in the inside in the winter. And the cool air is out there. That's basically how the heat pump works. And it works pretty well. But here in California, here in Los Angeles or in the smaller cities, we rarely ever use heat pumps because they have to use a lot of electricity in some cases. So a lot of people don't like to use heat pumps. Now, they're not sold here in Los Angeles, but they're all sold in Big Bear, Lake Arrowhead, because they don't have gas. So wherever you don't have gas, you have to operate a heat pump. But a heat pump is designed to operate not less than 45-degree ambient temperature. So if it's 45 degrees outside, your heat pump is not going to work as well. So you need to have what they call an auxiliary heat or an accessory heat, which they will add electric heat to the system that goes inside this module system. So once it gets down to 45 degrees, the electric heat automatically goes on to assist the heating mode in the home. That's called an accessory heat. Are they used a lot? Well, mostly in Big Bear where they don't have gas. I don't know if they have gas over there now, like Arrowhead and all those other places. I haven't been up there in years. The air is at a room temperature at this time. Where am I at? Okay, the walls. Okay, when it travels to a conditioned space within the house, as it flows towards the return air grill, the air in the room temperature at the same time. So that means even though it's giving air out, it's also returning the air in. If the air conditioner cannot give enough air back to the unit, then therefore the unit is not going to operate properly. This is where the filter that doesn't get changed affects the efficiency or the operation of the air conditioner. And if you're using a 99-cent filter, that's the only thing a filter 99 cents can catch is the LA Times. You need to use a pleated filter, which costs about $9 to $10. A little more expensive filter that picks up all the particles of the home. Kind of filter you want to have in your system. So as long as you're delivering the air in the residence, you must return the air back to the unit in order for it to work efficiently. And if it doesn't, then you're going to have issues. Here's an example. Are you ready? Let's assume we go to all our rooms and we start shutting the registers off. What's going to happen to that unit? It's going to starve for air. Because it's designed to operate to a specific CFM of air per room. You became the engineers. So whatever size that room is, that's the size of air it's going to supply. In order for this system to operate efficiency, it needs to bring that air right back to itself. It can't do it if you're starting to shut grills. Pasadena, California. Elderly lady up there, every Sunday, she would go in and close all the grills in the house and only leave her bedroom one on. That was only done in the winter time. She wanted all the heat to come in her room. What occurred is the heater was not getting enough air back to the system and not delivering enough air into the rooms. It was overheating the the heating system, and it was causing the furnace to turn off on high head pressure. A high limit switch. Meaning it was turning out because it was so hot. There wasn't enough air back to the unit. And that's what caused it to malfunction. So when I got there, I had to open her grills. It says it's not designed to be closed. They're designed to be open. Now in commercial applications, they will put a, yes sir?
There's some, you can close and open.
No. You can close and open, but they're not designed for that. They're designed to be open. Those are used to register the airflow of the air in that area.
The direction?
Yes, sir. In a in a commercial application, they use what they call dampers that will close the airflow to a specific area. But they're already pre-sized by the engineer based on how much air you need in that area. Different application. But you don't use dampers in a residential home. Not needed. Because you're sizing it up to the proper airflow per room. Where am I here? Okay. The air at room temperature, the duct system begins to return air grills. Okay. Okay, one more item I want to talk about real quick. Okay, we got that. You're going to need to read that information again. Okay, let's go back to our ductulator. Some cases, as a service technician, you will have to use what we consider rectangular duct. Rectangular duct or square duct are made by metal. You've probably seen them. Let's take, for example, a return grill in a home. Is that made out of duct? No, it's mostly made out of metal. It is what they call a plenum box or a metal return grill. usually sometimes they're 12 by 24, 15 by 15, and that's called the return grill, or the metal type plenum boxes, or metal type of triangular ducts they make, mostly used in small residential as well as commercial type applications. So to determine what size of airflow we're going to get in a rectangular duct, we have to know how to determine that. Looking at your ductulators, at the bottom section is a green section. Do you all see that? It says rectangular duct dimensions in what?
Inches.
Inches. Okay, let's look, turn it around. You see how it turns from left to right? Let's go to a 10 by 10. So what you do is you turn the dial till you get the line where it says 10 by 10. You see it? Both lines have to meet. Do you see it?
Yes.
Okay, looking at your arrow, your arrow looks like it's 10 and a half, or 11, right?
11.
Okay, now let's look at the .08. What's the CFM, the rectangular duct, 10 by 10?
460?
460 is about right.
480.
480, that's about right. That looks good. Got the idea? Okay, pretty easy?
Yes.
Okay, let's see how bright you are. Are you ready? You have 10 of them.
10
Same
of them.
paper. Same paper. Number 1, 10 by 12. Number 2, 14 by 14. Number 3. Am I too fast?
Yes.
14 by 14.
I'm sorry. Number 1, 10 by 12. Number 2, 14 by 14. Number 3, 10 by 14. Number 4, 12 by 16. Number 5, 14 by 20. Number 6, 12 by 12. Number 7, 14 by 14.5. Number 8, 16 by 16.5. Number 9, 18 by 18.75. And number 10, 20 by 20. Give me the CFMs in supply air .08.
do this morning? Great to be here with our good friend Cozy Roberts. She's reaching out to a new generation in a new way, turning her bestseller Founding Mothers, the women who raised our nation, into a children's book. It's called Founding Mothers, Remembering the Way. It's great to see you on a Monday. It's great to be here, Julie. Just a couple of you here. You have a lot going on. And I love the line.
You know, before the season started, I took Denver to win the whole thing. Before they started, before the NFL started, I've been a Raider fan for a lot of years. I love the Raiders, but I had to go with what's the best. And I think that, but you know, I was very shocked with Seattle. They shocked the blank out of me, and I watched them play. I said, wow, these guys are blank good. Wow. And they play against who this next weekend?
They got the 49ers at home.
Two good games, actually.
Yeah, they're great games.
They're the best 4 records in the NFL, right?
Yep. I was surprised to see. I never would put my money on Seattle anywhere, but they shocked the blank out of me.
Their defense.
That defense is beautiful.
Pete Carroll.
See the way that guy runs? He was running. He was still on the floor. I had to stand up and give him something. Man. He was still running to the floor. I couldn't believe it. That kid. He was great. Well, you guys should be coming up to the end right now, right? Now we're going to put all that knowledge together, what you just learned, and let's see how well you do. Steven, I got up this morning at 4. Worked on a furnace this morning, and then I checked another air conditioning furnace. I left Arizona at 12 o'clock. I got home, cleaned up, got off, just shoot out over here. There was an accident on the Highway 15, a semi-truck of eggs fell all over the Highway 15.
Because of the wind?
I think the wind had a lot to do with it, because the wind was like 65 miles an hour winds when I was coming down the canyon.
No, sí, no, sí, sí.
But I love it.
I woke up at 5. I wake up at 5 every morning.
Yeah.
Take the dog for a walk.
Yep. You live in Covina, Steve?
Walter Park.
Oh, okay, that's not far.
Walter Park, right down from
Oh, I know exactly where you're at.
right before.
Okay, okay.
Dog out for a walk. Get back in. Try to take a shower. Cold water.
Wow.
Water in
At least you got hot water.
I got
Got hot water, students. Okay, gentlemen, you ready?
Yes.
Okay. Let's assume, I usually draw a house out here. Do you guys, well, we only have one guy's been with me. We call this the Hal House, okay? The Hal House is about 1,300 square feet. I like to use that 1,300 square feet. And I'll give you a rough description of it, so you have an idea. This is his front door, and let's see if I remember. And this is bathroom here, and I believe we have a bathroom here. Look at that, whatever. And this is a master bedroom. This is the kitchen here, and he has a bachelor, so he has a big 70-inch screen TV. He has a sound system, big couch,
heat generators.
He has a stereo system there. He has it pretty good. Oh, and in the garage, he has a black BMW 500 and a Porsche Targa.
Wow.
That's it?
Okay, that's all he has. Is
He's not
toys.
doing that good then.
So it's a bachelor house. His problem is, at his home, is that it's difficult to get enough air in his house because he wants to cool. So the first thing you say to yourself, what kind of home is it? Is it a
Loose or tight?
tight or loose home? No, not some of the women that walk in there. It's the home. So you have to ask that your question. Is it a loose or tight home? Now, what is a loose home?
Older.
Older home. And what's
How
a
old is it?
50s is good, mostly 50s. What's a tight home?
Brand new.
Brand new home, well insulated, double pane windows, doors, all the accommodations you need to live comfortable. Not saying that older houses are uncomfortable, they're not insulated properly. Whittier, California. Customer just had a brand new air conditioner installed in her home. She complained it wasn't cooling enough. In Whittier, they have some houses there were built in the 50s. And when I arrived there, I walked into her house and she had a big screen television right there in front. And she had a big old couch and she had a big old coffee table with a big old gulp. What is that soda pop? The big old one? Big gulp. She had an ashtray that looked like a hubcap of a car and 2 lighters there and 2 pack of Marlboros and 3 remote controls. And she was hot. And she said she just had this installed and it's still hot. So I said to her, well, let me take a look. So I took out my $300 flashlight and I looked around. They did a good job installing it and they did the right size of ductwork. So in turn she says, I don't know why it's so hot in here. And I said to her, well, let's see what temperature the airflow coming out of the register is. So I took my laser gun. Laser was a thermometer laser. And I pointed it to the airflow coming out. And it was right around 56 degrees. Temperature outside was right around 100. And I said to her, it sounds like it's pretty good airflow coming out. Right size of duct for that area. So I took my laser and I went right behind where she was sitting. And right behind was a big old window. It must have been a 10 by 6 window. Single pane window. Put my laser on there and it was 100 degrees. Then I put my laser on their walls, outside walls, and it was 100 degrees. And I pointed to the ceiling, that was 110 degrees. So my next question, have you ever had insulation in your walls, in the attic, and you need to probably change your windows to double panes in order for that cool air to stay in the home? Because what you're having in this home is an infiltration of this heat. And she was kind of amazed. And she said the contractor that installed it never told her anything about that. That it would work okay. Well, he assumed it never get to 100 and certain degrees in the city of Whittier. Unfortunately, it did. But the point is, as a contractor or as a service technician, infiltration of heat is very critical on air conditioning system. And as a professional, it's always wise to share that information to the customer. Not that you're going to install installation material, because that's not your preference or your professionalism. We use those resources available, and she can find out who can do the installation for her walls and her ceiling, and someone that can change her windows to keep her cool air in her home. Maybe she will get a smaller gulp of soda pop and 1 pack of cigarettes. in turn, this is what you run into. The question is, if you have infiltration, can we have more air going in the home? You will defeat the purpose if you add more cool air to the home, because the secret about air conditioning is not how much air you bring into the area, it's how much heat you remove. Remember Vegas? Why is it when you walk in one of those hotels, it's nice and chilly, it's brisk, fresh air. You got a lady smoking here, and you got a guy smoking a cigar, and you can't smell it. Because they're returning that air constantly, and they're giving you fresh air all the time. They use a good filter system. People are comfortable. Now, you go into some of these restaurants, I won't mention any names, and you walk in there, and you can smell half the meat they're cooking. Because they don't clean the filters, or they clean the system, or their ductwork is very dirty, never cleaned that professionally, and you can smell it. Ductwork that's installed 15 years ago should be cleaned by a professional person that cleans it. Not a guy that walks around with a vacuum cleaner in the back of his back and with a long hose. That's not going to work. You need to have a Whipple brush that turns around and sticks through the ducts and picks up all the particles in the duct system. Especially if you have young children, you must get your ductwork clean. You can get your $300 flashlight and look in there and see how they look. You got to do an inspection. Sometimes older ductwork in homes will have a tendency to leak, and generally where they leak at is where the seals are, where they're put together into the plenum boxes. Or in some cases, you might have the cable guy crawl in your attic, and he decides to use the number 10 duct as a pillow. Does that happen? Yes. And you might have to go in there and fix that ductwork. So it's good to do every 3 years, do an inspection of the ductwork in your home or the customer's home. You get your flashlight and look around. If you see some damage, you report it. If you see something that needs to be done, you can report it to the customer and let them know that I found that you have some ductwork that needs to be repaired. Most easy, practical way to repair duct is using some type of form of zip ties, duct tape, and zip ties. And your book, it'll talk about that, and you can read that in your article when we give you your homework. Let's get back to our house for a second. And I assume that this house is 1,300 square feet. And what kind of cars does he have in there?
BMW.
And what else? Porsche. He's a very good bachelor, right? How's it going on, huh? Master bedroom, 2 rooms for his buddies when they come over, and a bathroom there, and he has his own bathroom and a shower probably in there. We are going to design the ductwork. Here we did a formula of the home. I'm not trying to be an artist, but there's 2 types of diagrams that you use. Are you ready? Number 1, I want you to think about that Porsche. I know, first thing you're looking at those rims, huh? What do they cost? $3,500 a rim for a Porsche? Nice 12 inches. Is it 12 inch or 22 inch? I don't know. 22 inch? Nice tires. So you see all that. You see it? You all see it? Okay. That there is considered a simplified diagram. Very simple. You see the whole thing, right? Now, we're going to give you a diagram of the unit. The diagram of the same car will be similar to what I did. A line, a line, a line, and some tires. Very, very simple. Schematic. This is what you see. So a lot of times when you are looking at a wiring diagram, you'll see two types of schematics, a simplified or a schematic. It's up to your discretion when you do your projects to draw it out the way you see it. In some cases, somebody would like to draw the entire part, or you will simplify it into a different type of diagram. And we'll get into a little more detail on that when we get into electric and schematic drawing. So now, let's go to this home. I'm assuming it's 1,300 square feet, and my airflow in CFM is going to be 1,300 what? CFM of air in this home. So we're going to install this furnace with the air conditioning system in the attic. So I'm going to draw it out here. And we're going to have the air going that way. This will be the AC unit, or this, in this case, this will be considered the coil, and this will be the heater. So the heater is designed to operate at 1,300 CFMs of air, so that when we are ready to do the duct sizing, we are going to come out of our, what they call plenum boxes. These are plenum boxes that they have that you could purchase and install. For example, I'm going to draw this plenum box right here. This is the angle you see. And then this will be the equipment. Let's assume you're going to make an 8-inch hole onto this plenum box. So we know the 8 inch is what? The ID or the outside? Inside. So we're going to make a hole. This is going to be an 8-inch. And how many inches should we be from the edge of this plenum box to the top? This is where the air comes in, hits the back of this, and bounces right out to this 8-inch. The theory is the distance between that point should be right around half of that hole. 4 inches. Pretty good? And the reason for that is why? Because when that air moves, it bounces right off the back of there, and you want it to shoot right out to the area of duct. You ready?
Distribution.
Distributed. You never, ever, ever put duct at the end of a plenum box. Never. You defeat the whole purpose of coming to school. No, my compadre didn't teach me how to do that. That's wrong. Because you're not going to pick up enough what?
Return.
Friction, velocity. You want a lot of air.
Flow.
You can't have it when you have holes on the other side. Not going to work. You ready? So let's assume I'm going to put a 16-inch duct right here. What is the distance between here and there?
8 inches.
Very good. So that will be 8-inch. Now I don't have any more room to install, so I can go to the opposite side of this, you can go on the other side of this, or the other side of that. But never, ever of the top of the plenum box.
Are they square or round?
This is rectangular duct.
Rectangular, okay.
Okay? So
Rectangular.
far so good?
Gotcha.
Okay, let's assume that this room here is a 200 square feet. This room is 300 square feet. Okay? And this bathroom is a
100?
50 square feet. So far so good?
Yeah.
Okay.
Thank you.
Let me get a different color here. So, what size of duct do I need here?
You need a 9-inch duct?
Okay, 9-inch. What I'd like you to use in this class for this semester is use even numbers only for the purpose of learning. So, what size of duct do I need in that room?
10.
Very good. So I'm going to put a 10-inch duct in here in this room. And in the bathroom, what size? What? 50 is what? So we're going to go with a what? 6. 6 inch. And this other room, what are we going to do? What's this, 200 square feet is what?
Go with 8.
8 inch. Okay, very good. Okay, are you ready? How many CFM is the number 8? Okay, let's just put 200 CFM, okay? 210. 6 inch?
6 inch would be 100.
Okay, 100. 10 inch? What?
300, 400.
300, okay. 380?
380.
Okay. CFM, okay. So let's add all these three together.
Okay.
We got 380, 210, and 100. What's the total?
690.
What? Okay. CFM, right? What's the size for 690 CFM? Huh?
I'll tell you right now. 14 inch?
13.
It's a 12 and a half.
12 and a half, so what are you going to use?
I'll go to 14.
Okay, so that means off of this plenum box,
All right.
you're going to come off here a 14 inch.
Ah.
So from here you're going to go up 14 inch, and you're going to tee off with a what? A 10.
10.
Right here's a TY, 10.
Okay.
Now from here to here, you ready?
Yes, sir.
So what is 210 and 100?
That's 310.
310, and what's the size of 310?
10 inch.
10 inch. So from here, you're going to tee off with a 6 inch, and then you're going to tee off here with a 8 inch, using a number 10 from this point. Do you see how that works?
Absolutely.
Huh? Any questions? Some of you guys are like in a daze.
Do it one more time.
So the reason why we didn't use a 10 was because there was already an existing one. Is that why?
Well, we did the measurements on the square feet of the room, how much air we needed for that room. And we said that that room needed a 10 inch, that other room needs a 6 inch, the other room needs an 8 inch. We use that as a calculation to do our establishment of designing the ductwork for this house. In order to have one duct coming from the plenum box, rather than having 3 of them coming from that plenum box, we decided to use one large duct and split it up 3 ways.
Gotcha.
Now, can I do that? Yes. Can I do one at a time from that plenum box? Yes. Is it feasible? No. And the reason for that is why? Too many what?
Too many holes.
Too many holes and too many turns. Pretty easy? Now, for your homework assignment, I asked you to do some diagrams on your house, remember? You all did some measurements of the room. So what I'd like you to do for your homework assignment this weekend is to design your air conditioning system using the total square feet of your home. Now there you have to think a little bit. My suggestion strongly is probably get with your partner and maybe study with him on that and get an idea of how you're going to do it. Here's the formula. On page 8.7 is the same formula they use. guys are not gonna sleep good tonight, thinking about this. Right, Mr. Contractor? Got you thinking already. Your brain's going 100 miles an hour, trying to figure that out, huh? I love it. Good for you. Any questions on it so far? I'm here now.
What is that formula?
Formula? Page 9.7 in your book, similar to what we just did.
9.7?
9.7, right in your book. Same thing we did.
8.7?
Oh, let me put my glasses on.
Yeah, 9.7.
9.7.
9.7 in the book.
Okay.
So you want us to design
The homework assignment last week was to do the figuring of each room in your home. Size of each of the rooms, because we didn't have a ductulator last week. So you did that. Now you're going to design the air conditioning system per the house. Size of the rooms you already have. You have the duct size for that room. Yes, sir.
Does it matter? I mean, I'm assuming it matters the length of the run, right? So how do you-
Yes, sir. We just talked about that. What's the maximum length of the run?
100 feet.
Within 100 feet. Now, that's a good point.
Anything less is okay too?
Yes, sir. Anything above that, you might have to go with a larger duct. Like I went from a 14 to a 10, from a 10 to a 6 and an 8. Rather than going an 8 all the way to the plenum box, I went 14, 10, 10, 8, 6.
So, what would you use from like a long hallway to a room? Would you not put a supply to the hallway?
Oh, yes.
Yeah, right. Just a small supply.
You could do
depending on
that. Is it feasible for a hallway? Most likely, in some cases, you need to have the return there. The
Yeah.
return is
Yeah.
the return is going to be where the most traffic travels, and not your bedroom. Not the master
Hallway.
bedroom.
Hey, my bad.
You want to have it the hallway. Most traffic travels. That's where the return is. Remember that air also needs help to move around in a home.
Did we do this?
The bodies move the air around. This is why the thermostat goes on and off all the time.
210.
Sometimes when a customer or a family that goes to bed, they have a tendency to shut all their doors in all the bedrooms. And they don't get good circulation in their beds. And the reason for that is the bottom of the door is not cut enough for the airflow to come out. Or they don't have a return in that bedroom. So if you ever check your door, it should be between an inch and a half gap at the bottom of your door. Some people don't like that. They like it sealed. That's to their discretion. But to have good airflow in the home, you must have the air coming right back to the return. Most air returns are in the hallway, not in the kitchen. Pasadena, California. There was a customer that installed their own air conditioning system, and I was out there to check it. He had his return air of his furnace in the bathroom. In the bathroom.
The bathroom?
The bathroom.
And then he always took hot showers?
I don't know about the showers, but when I walked in, the bathroom was big. When I walked in the bathroom, they had the whole system there, the return and everything. And I asked him, I said, who installed it? He says, I did. He had a smile on his face. I said, you should have got a professional to install it for you in a proper area. And of course they did later on. But the point was, I even took pictures of it because I thought nobody would believe me. But those are the things that happen. So you don't want to install a return grill over the kitchen in case somebody's cooking. And you never want to install a return grill near the bathroom doors. There are some people that accidentally do that. I don't say the people in general, but the contractor does, not thinking that that's the bathroom. When they open the doors, the fumes come in. And everybody's in the house. You have to be cautious about that. Any questions so far, gentlemen? You know what your homework assignment is? Yes, sir.
You want us to draw it out.
Draw it out the way you would read it yourself. And show it to me, okay? Okay, homework assignment for reading. You ready? Section air distribution system, 9 to 9:43. Answer the 15 questions. You will hand that in next week on Monday,
9:43,
9.43.
and answer 15 questions.
15 questions.
Okay.
And you're gonna really enjoy this section about airflow and some of the registers.
So homework is reading, and then I'll do a schematic on the AC unit of
Your
your house.
AC on your home.
Okay.
Now, the paper that you did all your formula numbers on, you guys got an idea? You're gonna need that to go do your formula for your home, so you'll take that home with you too. I would prefer that when you finish your homework, staple all that together into one paper, so that I can grade it. And, I'm gonna have a, yes sir, I'm
Okay.
gonna have a folder out here. It's a regular folder, and you will put all your homework in it. Yes sir.
You want the assignment that we did today in class?
You're gonna hand it in next week,
Altogether.
staple all together. We have the EPA books available, so you need to study for the EPA books. February the 4th, we're gonna have a class on EPA. It will, on the 4th, that will be at Roland. I'm gonna have all the students there, we're gonna go over it, and then at the end of February, we're gonna do our testing. You guys will probably not be ready for testing, but at least you'll have your books and you'll at least get an idea of what we need to study. Any questions so far? Any questions? Okay, gentlemen, I'm gonna let you go out a little early, you got a lot of work to do. I look forward to seeing you next Monday, those who need their EPA books, come and